All right, everybody, hello and welcome back. Today what we're going to do is we are going to explore infinite geometric series. So I'm kind of giving away a little bit of information in the title there. Really, we're trying to explore infinite series in general. And now what an infinite series is, it is when we take the sum of an infinite number of terms in a sequence. So what we're going to do is we're going to start by exploring what the sum of the first 5 terms of a sequence described by the explicit formula 16 plus 2 times n minus 1. So hopefully we realize that this is an arithmetic sequence because we are adding 2 every time. And so if I were to go ahead and type that into a calculator, we would get a sum or a value of all right, guess we won't be using Apple Pencil today. The sum is going to be 100. Now, next, if I go ahead and add the next 5 terms as well, so that means, the next 10 terms as well, that means I'm taking the sum of the first 15 terms in this sequence, I would get 450. So now what we can see is while we are adding more and more terms to an arithmetic sequence to find the series, our sum is just going to grow and grow and grow. And part of the reason it's growing is because we are adding a positive 2. But even if this were to be a minus 2, our solutions would just get more and more negative. It would always continue to grow, just more negatively. So we can't calculate the sum of an infinite arithmetic series, which is why we are focusing on geometric. So let's take a look at the next couple examples. We have, why don't we skip this one to make our lives a little bit easier here. We've got the geometric sequence that is described by the explicit formula 2 times 1/2 to the n minus 1 power. And what we're going to do is we're going to calculate the sum of the first 5 terms. Now, if we go ahead and we plug that into our calculator, again, you could use Desmos or your regular calculator, we are going to get 3.875. So a pretty small total. The value of the series is not very large, but that's because our terms are getting cut in half, right? Because we have a ratio of 1/2 every time. So let's see what happens if we were to add 10 more terms. So now instead of adding the first 5, we're going to add the first 15. So our series is going to have a value of 3.99, technically 9875. And I'm rounding a little bit there. So we're adding 10 more terms because you can see the value of the series does not really go up that much. So if we were to attempt to find the sum of the first 50 values, well, that is just going to give us 4. So again, we are adding 35 more terms, but the series is only growing by a very, very, very small amount. And part of the reason that is if we were to try to find our 49th term, we would take our explicit formula, and we would plug in 49 for our n value. And this gives us 3.55 times 10 to the negative 15th. All right, and what that means is that a scientific notation where if we were to take the 3.55, we move the decimal 15 places to the left. That means this is a very, very, very small number, and it gets even smaller if we were to find the 50th term. If we were to plug in 50, we end up getting 1.77 approximately times 10 to the negative 15th. Again, a very, very small number. So as we can see, what happens is we can estimate what the sum of an infinite series is by finding what we call a partial sum. And that is the sum of a portion of the infinite terms. And now the reason that is eventually towards the end, our terms get so small that we are essentially adding 0. So in our example, these two values right here are incredibly small. They're basically nothing. So they don't really contribute much to our total. So if I were to add 100 more terms after this, again, those terms are so small, it doesn't really change the value of our total, which is why we can calculate the infinite series below. Now, the way we can do this is actually using a formula. So it says we can calculate infinite series for geometric series with an R value that is between -1 and 1. To calculate it, we use, and this is S sub infinity equals A sub 1 divided by 1 minus R. Now, we can only calculate an infinite series when R is between -1 and 1. What that would mean is that our terms are going to get smaller and smaller and smaller until they are eventually 0. If we wanted to come back and look at this example here, our ratio value is 3. What that means is your terms are going to get bigger and bigger and bigger and bigger and bigger, and therefore their sum is also going to get bigger. If we made this a -3, again, we are outside of -1 to 1, and this just means that each term would get more and more negative, so therefore the sum would become larger and larger and larger, just negative values. So again, we can only calculate the sum when our R value is between -1 and 1, but when it is, we can calculate the infinite series using this equation. So here's my example here. If I just kind of get rid of some of this, if we were to take the sequence, described by this explicit formula, and I wanted to find the sum of all of the terms ever that are going to be in that sequence, the infinite series, then I would take my first term, which is 2, divide it by 1 minus my ratio, which is 1/2. Now, if we do that, we get 2 divided by 1/2, which is really just 4. All right, so this works in many different cases. Let me give you another example just so we can see. If we have -16, +4, -1. This is a similar example to one we've used in a previous video, but as we can see, we are multiplying by a ratio value of -1/4. And again, my terms are getting smaller and smaller and smaller, so eventually they will be approximately 0, which means this series will essentially stop growing. This R value is between -1 and 1. So what that means is we can find the sum of the infinite series. Again, that formula is A sub 1, which in our case is -16, divided by 1 minus our ratio, which is -1/4. And again, I do apologize. Once again, writing with my finger here. So we can evaluate this to become -16 divided by 5/4, which is going to give us, and again, we could just do that on a calculator real quick. We have -16 divided by 5/4 is going to give us -12.8. Now, that sounds a little bit interesting because our first term is -16, which is more negative than -12.8. But let's remember that the second term is positive, then we have another negative, then a positive, then a negative, then a positive. So that doesn't mean that the sum is going to be more negative necessarily than -16. Just a quick recap. We can calculate an infinite series, but only for geometric series when the R value is between -1 and 1. And when it is, we can use this formula to approximate its value. Okay? As always, thank you for listening. If you have questions or concerns, please feel free to ask. Just one more quick tip. Remember, you cannot plug this into Desmos. I see students try to do this all the time where they will write our summation notation. They will plug in the first value, our ratio to the n-1, and then they will look all day for the infinity symbol to put up there. You are unable to do that on Desmos. You can't do it on your calculator, which is why we use this formula. Okay? Thank you. Have a good evening.